Lesson 22, we're going to extend our knowledge of measurement units and we're going to use the distance formula. The distance formula is distance is equal to rate times time. So our first activity was done in the hallway. We used timers and we did some walking trials and some running trials for time. The distance that we were using in that example was 50 feet. And so for each of those calculations, you would use 50 for the distance. What you're looking for is the rate, and the time will be the time that you have recorded from that trial. For example, if I had 6 seconds for my time, then my equation would be 50 feet is equal to whatever the rate is times 6. One rule of thumb that's very important. If you have a number on both sides of the equal sign, you need to do the opposite operation than what is being done in the original equation. In the original equation, we see that this is multiplication. This is another way we can write multiplication with an asterisk. So since the 50 is on the left of the equal sign and the 6 is on the right of the equal sign, we need to divide 50 by 6 in order to find out what the rate is. And 50 divided by 6 is 8. 8 times 6 is 48 with 2 left over. So we have 8 2/6 for our rate, which simplifies to 8 1/3. And these units would be feet per second. It's extremely important that you label the numbers that you have. Otherwise, you won't be able to say what kind of unit this is. Feet per second. I know that because the 50 is feet, and we divided by 6 seconds, feet per second. In exercise 2, part 1, they tell us that Chris Johnson ran the 40-yard dash in 4 2400 seconds. What is the rate of speed? We're going to round our answers to the nearest hundredth of a second. We do not round until we get to the answer, so please be careful with that. In the same way, we know that the distance is 40 yards, and we know, I'll use the traditional X for multiplication. No, I don't want to do that. We use the X, it looks like it's a variable, so we don't want to use the X. And it was done in 4 2400 seconds. The rate is the part we're looking for. You should notice, just like our last exercise, that the 40 and the 4 2400 are on opposite sides of the equal sign. So we'll need to do the opposite operation. We'll need to divide. We're going to divide 40 by 4 2400. And when we round that, we'll get 9 4300 yards per second, because it was 40 yards and 4 2400 seconds. Yards per second. In part 2, we're reminded that we were converting units of measures using unit rates. If the runner could keep up this speed at a constant rate, how many yards would he run in an hour? So first of all, what we want to do is figure out how many yards he would run in 1 minute. We know that his rate is 9 4300 yards per second, and we know that there are 60 seconds in 1 minute. So we will take the rate, 9 4300, and multiply it by 60 seconds. which will give us 565 and 80 hundredths yards per minute. And then in part B, they ask us how many yards would he run in 1 hour. So likewise, since there are 60 minutes in 1 hour, we will multiply the answer from part A, 565 and 80 hundredths, and we'll multiply that times 60 minutes in each hour. And that will give us 33,948 yards per hour. There is a suggestion that we could complete the same problem in one step. We can multiply the yards per second by the seconds per minute, and then by the minutes per hour. This is very convenient to do with the calculator. By crossing out the units that are in both the numerator and the denominator, we can actually find out what the units are at the end. So noticing that there are seconds in this denominator and in this numerator, those could go away. There are minutes in this denominator and this numerator, so those could go away. And finally, we would end up with yards per hour. The number on top first and the number on bottom last. And the multiplication will still give us 33,948. How many miles did the runner travel in that hour? Well, since our answer was already in yards in 1 hour, we need to know how many yards there are in 1 mile. Even if all you know is the number of feet in 1 mile, you could take the number of feet, 5,280, and divide it by 3 feet, since there are 3 feet in each yard. And that would tell us that there are 1,760 yards in a mile. From that point, we need to take the number of yards that our runner was traveling in an hour, 33,948, and we'll divide it by 1,760. And that will tell us that the runner went 19 3/10 miles per hour. Finally, our examples for a road trip are looking at a rate of speed and assuming that that rate of speed can be maintained. I drove my car in cruise control at 65 miles per hour for 3 hours without stopping. How far did I go? Again, the distance formula. Distance is equal to rate times time. So our rate is 65 miles an hour, and we were traveling for 3 hours without stopping. You'll notice that the hours can cancel each other. And that will give us 195 miles in a 3-hour time period. Example 2, on the road trip, the speed limit changed to 50 miles per hour in a construction zone. And so traffic moved along at a constant rate of 50 miles per hour, and it took 15 minutes, or 1/4 of an hour, to get through the zone. What was the distance of the construction zone? In this case, we don't know the distance. We do know the rate, which was 50 miles per hour, and we also know that the time that we spent traveling that was 25 hundredths of an hour. So in this case, our two numbers are both on the same side of the equal sign. So we will actually multiply because they are in that side. And 50 times 25 100ths is 12 and a half miles, or 12 and 50 hundredths miles. Remember, the distance formula is distance equals rate times time. As long as you know two of these three numbers, you can find the third.